Okay, this video is talking about area of triangles and trapezoids. But first, let's cover some terminology that you're going to need to know. Base and altitude, and this applies to both triangles and trapezoids. The base for a trapezoid are the parallel sides. So when we refer to the base for a trapezoid, we're actually talking about two sides. The altitude, sometimes known as the height, or actually the height is the distance of the altitude. That's a segment that's perpendicular to the base, so we have two bases here, so it's actually perpendicular to both bases, with endpoints on the baseline. So that is the height, but also referred to as the altitude. For a triangle, any side of the triangle can be referred to as the base. Here we have two examples of triangles. On the left, the 3 will be our base, and the 4 will be the altitude or the height for our formula. And then the example on the right, 4 will be our height, and 6 will be our base. So now let's take a look at the formulas themselves. There are two formulas for the area of the trapezoid that you may see. This is the first one. This is in your textbook. 1/2 times the height times the sum of both the bases. A would be the top portion of the trapezoid and B would be the bottom portion, but they refer to both of them as bases. For the SOL, this is going to be the formula they use on the formula sheet. Same thing, the only difference is they use base 1 and base 2 instead of A and B. So again, textbook, SOL formula. Now before we discuss the area of a trapezoid, let's look at the area of a rectangle. The area of a rectangle is length times width. Now in terms of our trapezoid, we could really replace the length with base 1 and base 2, relating that to our trapezoid, and the width with the height, which would be right here in our formula. So looking at it both ways, traditional length times width, and then using the area of a trapezoid to solve for this problem, you can get the same results. So 8 times 3 would be 24, and then 1/2 the product of 3 and the sum of 8 and 8 would get you 24 as well. So the placement of where this 1/2 is a little bit confusing because you're thinking 1/2 the height, it has something to do with the height. But in fact, what you're doing is you're trying to find the mean of the lengths to get that length here. This, you don't need to find the mean because it already gives you the length. It's the same on both sides. Here you're adding them together and then taking half of that, finding the mean, in order to multiply that height times the mean of the bases. Now let's look at the area of a triangle. It's 1/2 base times height. Again, let's first take a look at how this relates to the formula of a rectangle. Now again, the rectangle would be width times length, but I've replaced that with height times base. And I know it's a rectangle because I've just marked it all up as a rectangle. Parallel sides, 90-degree angles on all 4 corners. So the area of a triangle is just taking the area of a rectangle, and because we're only trying to figure out half of that area, that's why we use the 1/2. So half of a rectangle gives us the area of a triangle. So just summing up, the area of a trapezoid is 1/2 the height times the sum of base 1 plus base 2. And then for a triangle, it's 1/2 the base times the height.